Explorer's Guide to World Weather. Introducing Earth. Oceans and airs whirl around Earth. Ocean waters can wash the shores of North America, also wash the shores of Asia. The breeze that blows surges in South America rustles leaves in Africa's trees. Yet, regions on Earth can be very different from one another. In some places, people never need a heavy coat. In other places, people never go without one. Farmers pray for rain in some places. In other places, rain falls every day. Let's look at why different parts of our planets have such different weather. How scientists measure weather. How many words can you think of to describe weather? Hot, cold, warm, chilly, rainy, sunny, snowy, foggy. The list could go on and on. All these words describe two things, temperature and precipitation. Temperature is how hot or cold a place is. Precipitation is moisture that falls to the ground in the form of rain, snow, sleet, or hail. To check the weather of a place, we measure two conditions. How hot is it? How wet is it? Climate is simply the average weather in a place over long periods of time. Weather information can be recorded on graphs. Look at the temperature graph below. The graph shows information when the weather is Sydney, Australia for the first 6 months of the year. The number of the list sides show the degrees of temperature. Now look at the precipitation graph. It is very similar except that on the left side, the numbers show amount to precipitation in each inches. By collecting weather information over time at many places, scientists have discovered that Earth has many different climate patterns. Climate Field Guide. What determines Earth's climate patterns? It all starts with the sun. The sun warms our planet, but its warmth is spread unevenly over Earth's surface. The equator is an imaginary line that circles the middle of Earth like a belt. Areas near the equator tend to be much warmer than areas far to the north or south. Because Earth is shaped like a ball, the sun's rays hit Earth at different angles at different places. The sun rays are most described around Earth's middle, the least direct at the north and south poles. Try this. Mark an X in the center of the sheet of paper. Have a friend hold the paper so it's facing you. Shine a flashlight at the paper so it makes a circle of light on the paper around the X. Have your friend slowly tilt the paper far away from you. As the paper is tilted away, the circle of light will stretch to become an oval. The same amount of light is being spread over more of the paper. As a result, even though the X on the paper is still in the light, it is getting less light than it was before. In the same way, because Earth is shaped like a ball, as you move north or south away from the equator, Earth curves more and more away from the sun. Earth's polar regions are cold because they receive less direct sunlight than areas near the equator. Latitude. Latitude is a system we use for measuring distance north and south of the equator. The equator is 0 degrees latitude. The North Pole is 90 degrees north latitude. The South Pole is 90 degrees south latitude. The smaller the latitude measurement, the closer a place is to the equator, greater than latitude measurement. The farther it is from the equator, climates at or near the equator are generally warm. Climates far from the equator are generally cold. Elevation. Elevation, the height above or below sea level, can also affect climate. Imagine you were at the equator standing on a high mountain top. You will be in a cold climate. That's because the temperature of the air drops about 3 degrees Fahrenheit for every 1,000 foot increase in elevation. Mountains can also affect precipitation. Air contains water vapor. Water in the form of a gas. Air tends to move around the planet. When wind ramps into a chain of mountains, air cannot hold as the air is upward, where it cools. Cool air cannot hold as much moisture as warm air, so air drops its moisture as rain, snow, sleet, or hail on the windward side of the mountains, leaving the other side, the leeward side, very dry. Dry regions, because by the mountain's walls, are called rain shadows. Large bodies of water. Large bodies of water affect temperature and precipitation too. Water heats up and cools down more slowly than the surrounding land. As a result, large bodies of water act as a kind of insulation on the areas of land next to them, keeping them from heating up or cooling down too quickly. Places near large bodies of water experience mild winters and summers. By contrast, places located far from large bodies of water often have extreme temperatures, very cold winters and very hot summers. In those places, the air does not hold enough water vapor to insulate against the extremes of temperature. Ocean currents also play a part of climate. Cold water currents flow from the poles toward the equator. Warm water currents do the opposite, flowing from the equator toward the poles. Air above these currents slowly becomes the same temperature as the water. Consequently, if a prevailing wind blows from water to land, it generally warms or cools those regions. With its high latitude, Western Europe should have a fairly cold climate. However, a warm water current, the North Atlantic Drift, warms the air above it, giving Western Europe a middle climate. This current also gives the region a wet climate, because warm air can carry more moisture than cool air. The air that flows over Europe is loaded with water vapor. People in this rainy part of the world need raincoats and umbrellas. Most climates along the equator are hot all year round because of the direct sunlight. They receive climates in other places on Earth change with the seasons because of Earth's tilt. Look at the diagram above. In January, the northern hemisphere is tilted away from the sun, which causes the winter there. In July, it is tilted toward the sun, which causes summer. The southern hemisphere has reversed seasons because it tilts in the opposite direction from the northern hemisphere. Exploring Earth's climate patterns. You just had a quick tour of the forces that affect Earth's climate. Pick a place on a globe. Think about the factor that affects its climate. How far is it from the equator? Is its elevation high or low? Are the mountains or large bodies of water nearby? What season is it there right now? If you can answer these questions, you can probably guess what the weather is like there, even without leaving your home.